Good afternoon, everyone, and welcome to today's ParaBoss webinar. ParaBoss is a joint initiative of AWI, MLA, UNE, and AHA, Animal Health Australia. Thank you for being here today. We're going to be talking all about proactive management for sustainable parasite control. For those of you who don't know me, my name is Fiona MacArthur and I work with the ParaBoss extension team. Shortly, we're going to be joined by Dr. Matt Playford, who will be our presenter for today.
Thanks, Fiona. Now, I just want to introduce the topic today. So, proactive management for sustainable parasite control in livestock seems a bit of a wordy introduction or title, but really we're talking about integrated pest management. And when it relates to parasites, that means using everything in the book to try and control parasites. No holds barred. We're going to be exploring some of the sound, tried and proven ways for controlling parasites in livestock, as well as the ways that are a bit less proven that probably need to be considered. Now, that's because we do have problems with resistance with chemicals, and some people want to farm as an organic operation without the use of chemicals. So this presentation will cater to both sets of audience. So first thing we want to look at is the agenda. The key concepts in sustainable livestock management. What are the big picture, the helicopter view items that we need to think about? Then we're going to be looking at the biology of parasites and livestock, get down to the nitty-gritty with pasture and animal management, how to monitor animals, and then look at some of the key issues in geography and genetics. So starting off, we have to acknowledge that we were requested to run this webinar by the Australian organic industry, and they have just had their industry awards, and no doubt many of the members will be tuned in. Okay, well, let's start off with the first concept in integrated pest management. Is it possible to keep livestock with no or low chemical use? And the first thing we have to look at is, what is it that chemicals provide anyway? Well, the first thing is safety nets for times when the other options don't work. And many of our livestock producers, of course, are familiar with this. You have a bit of a crisis, an animal health crisis caused by internal or external parasites, and you need to reach for a solution that will be rapid, that will save lives, that will stop animals from suffering. And that's particularly true when we're running high stocking density, high stocking rate operations in the high rainfall areas, particularly the warmer areas where parasites are a particular problem. Second thing is they're a tool for increasing stocking density, productivity and profitability. And that is the main reason why they were introduced and continue to be widely used. And the third thing, of course, is animal welfare. So internal parasite problems will kill animals. External parasite problems will cause severe distress. As well as that, they act as vectors or the transfer organisms for internal parasites such as tick fever or other vector-borne diseases. And so we can actually use chemicals to prevent those diseases from occurring. Okay, what are the major problems with chemicals? Well, the first one is they don't last as long as we'd like them to, and that's really because any use, and I've made a slightly judgmental comment there, incorrect use, any chemical use leads to resistance because only the resistant worms or parasites survive a treatment. Okay, so that's the first thing, and resistance is becoming worse each year, and it's particularly bad for worms in the guts, of our livestock, for liver fluke, but also for flies, lice, and ticks. The second thing is potential residues, and that goes for meat, wool, and for milk-producing animals. Now, thankfully, we do have a very competent regulator in Canberra, the APVMA, or sorry, in Armidale. Hello to everyone at the APVMA, who set guidelines that are legally binding for withholding periods for meat, wool, and milk. And so if we follow them, we should have no problem, right? Well, not quite, because we still have some markets which won't accept any chemical use. The third thing is we have potential toxicity for animals, humans, and the environment. And we have a lot of experience now after decades of chemical use, and most veterinarians are very aware of the products that will cause toxicity and will have precautions in place both for preventing toxicity from occurring and treating them once it's occurred. And the fourth thing is market access. So organic certification is very important for access to certain markets, and there's very low tolerance for any chemical use and strict guidelines around the use of those chemicals. Okay, so how do we manage before chemicals? Well, the first thing was a low stocking rate. Most of the older farming systems allowed for a very low stocking rate, and so that diluted the worm problems for starters and allowed animals to have fresh pick wherever they walked, and that solved a lot of the problems. Second thing was daily shepherding. So if you look at some of the more ancient techniques, you'd have throughout Central Asia, the Middle East, even in Europe, you'd have daily shepherding, and that would allow people to avoid the high parasite load hotspots. Third thing is no graze systems where animals are fed hard feed. This was very common, particularly in North America and in Europe, where animals were housed for most of the time and given feed. And of course, they weren't allowed out to graze on the parasite-laden pasture. The other thing is strict selection for resistance. And in this case, resistance has a slightly different meaning to when we're talking about chemical resistance. This is really immunity towards the parasites and resilience. And you can select for both of these. They are both genetic factors of the livestock that we're keeping. Now, of course, some of this is accidental. Like, for example, with wild animals, you'll find that they have very good immunity against parasites and resilience simply because the weaker ones die. And when we have no chemical systems, this may occur as well. And so with integrated pest management, a very important part of our strategy is to use genetics to select for the animals that have both the greatest immunity and resilience to parasites. And the fifth thing is people who managed animals without chemicals back in the old days just had to have a higher level of acceptance of sickness and death. Now, that's something that I can say even in my career, spanning 36 years as a veterinarian, that I have observed a mind shift in people in modern times towards tolerating sickness and death. There's very little community acceptance of sickness and death in livestock today, and there has definitely been a shift away from tolerating high levels of it. Okay, so this is an example of shepherding. This is from Central Asia, where here the shepherd is getting the goats out of a corral, where they've been kept overnight, and it might be necessary for protecting them also against wild animals. And the shepherd will take the goats out to a different place every single day. So they're grazing on a different pasture every day. And because of that, they're able to reduce the parasite burden on the pasture. This is how they do it in Malaysia. I was over there last year, and you can see this goat has a rope tied around its neck, and the people who are looking after the goat takes them out to a nice patch of grass on the roadside, ties it up, and leaves it there for the day. And of course, the next day they go to a different place and keep on rotating around so that they're avoiding the parasites building up. Now, this type of tethering is largely frowned upon in societies like Australia, and it's not an acceptable animal management technique here, but it's still widely practiced in some areas. And this is back in Australia. These are meat goats, boar goats, that are confined in a yard and then put out into a different paddock to try and keep the paddocks clean and fresh during the grazing period. But they're confined for half the day in a yard. So all of these are methods of using daily shepherding to improve the health and decrease the exposure to parasites of the animals. Okay, but what happens when we have an animal health crisis, when all of our precautions don't work? Well, we can go in with supportive treatment. We can improve nutrition, we can use electrolytes, and there are some treatments that are unregistered that may not also be proven. So they might come from folklore, such as botanical treatments and other things that may or may not work. The second thing is you can go in with targeted selective treatment. So only treat the animals that really need it. And if they're in an organic supply chain, then they can be identified and removed from that organic supply chain. Now, this is a very valid method for improving animals management anyway, because targeted selective treatment means that we actually use less chemicals, for example, drenches, anthelmintics for worms, and only the animals that really need it are getting it. So this is actually being commonly used throughout the world right now as a routine management system, particularly for small flocks and herds of animals. With larger herds, it's a lot more difficult to achieve, but it's not impossible. And we can actually use techniques such as automatic weighing. And this is a fantastic system that's revolutionized our ability to gain a handle on the weight gain or the lack of weight gain of a big mob of animals simply by putting a set of scales into the paddock and allowing them to weigh themselves. You tempt them with some salt lick blocks, for example. They come onto the weigh scales, weigh themselves and walk off. And it makes possible a technique where if we're individually identifying animals, for example, with an electronic ID, we can even identify the ones that really need treatment and the ones that are gaining weight well and probably don't need treatment. The third thing we can do is just come in and do a blanket treatment. Now, this is, again, a very sound method, and it's very widely practiced. And then if the animals are in an organic supply chain, you can find alternative markets or observe the withholding period. And I believe that when animals are treated for animal welfare reasons, the three times the withholding period is expected. But I'm not an expert on this, and I'll encourage you to seek advice from your auditor or from the organics certifier. Okay, so that leaves us with a list of things that we can do for an integrated pest management worm control program. So as well as the treatments, we've got worm testing, paddock management, flock management, and tools and knowledge. And that gives us a bit of an idea to be able to rank our own performance in each of those different areas and work out what areas we're not exploiting currently for proactive livestock management to prevent worm problems. Now, this is also a little chart that's used in the ParaBoss worm control workshops that are being run throughout Australia at the moment. And if there's one coming up in your area, I'd strongly advise you to go along, because in about half a day, you can go through all the different techniques in great detail and work out what are the most practical ones to apply on your own property. Okay, well, let's just change gear a bit and look at the biology of the parasites and the animals to try and work out how to best exploit them. And the first place we need to look is the life cycle of the worms. So for the most common worms, such as Barber's pole worms, brown stomach worms, black scour worms, and Nematodiris, we're looking at a direct life cycle where the animal spends part of its time inside the animal. And that's actually a very predictable part of the life cycle, because the animal's got a constant temperature and uses its homeostatic mechanisms to keep things flowing along just perfectly for the parasites. And then we've got a period on the pasture, and that's much less predictable, because the weather conditions will greatly influence how well the parasites develop on the pasture. So generally, we tend to think of the parasite life cycle as taking about 21 days inside the animal, and that's because from the time they eat the infective larvae until the time that they mature and lay eggs and the eggs appear in the feces is generally about 21 days. We do have a couple of outliers though. Nematodiris worms, which are the thin-necked intestinal worm, they're only 14 days earliest. And even Barber's pole worm in sheep can be as quick as 16 days. So don't be surprised if you sometimes get very rapid maturation and eggs appearing earlier than you would expect. Okay, the other thing that's important to remember is the quickest that the worms can develop on the pasture is 4 days, but they're not in a hurry. They will take up to 150 days if the conditions are right for that long period of maturation. That's usually during the winter or the shoulder periods where they're in no hurry, their metabolism slows down, and they take their time to develop from the eggs through to the infective larvae on the pasture. Another really important thing to remember is that when Barber's pole worm eggs hit the ground in the dung pile, they've really only got about a week, 5 to 7 days to hatch out and become first stage larvae, or they will die. Now, it's different for the other types of worms, which can last up to 30 days or even more. But for Barber's pole worms, if it's not wet and it's not warm, when they hit the ground, they will die. So that's a very important feature of the Barber's pole worms to keep in mind. So the key things that are driving worm development on pasture are temperature, oxygen, and moisture. Now, we tend not to think about oxygen too much. We tend to think it's a bit of a constant. There's only a slight variation between the centre of a dung pellet, for example, in sheep and goats, or a dung pat in cattle, and the outside. But that will affect the development of eggs that are right at the very centre, because they won't have enough oxygen to develop in some situations. But temperature and moisture are constantly changing, and we need to have a look at how they impact our worms. So each worm has its own ideal conditions. For example, the Barber's pole worm, which is Haemonchus, which is the orange line there, has an ideal larval development temperature of about 27.5. whereas a brown stomach worm has an ideal development temperature of about 19.5. Now, barber's pole development pretty much stops down at that, low teens. As soon as it gets into single digits, then all action stops for barber's pole worm. But the brown stomach worm and one of the black scour worms, Trichostrongylus vitrinus, they'll continue to develop, way down almost to freezing point. And the other thing about T. vitrinus is its ideal temperature is only 13 degrees. So it's very happily developing through to maturity and getting ready to become an infective larvae in the late winter, springtime, and even in the autumn. Okay, well, that takes care of temperature. What about moisture? Well, in the location where the larval worms are living, it has to be between 40 and 80%. And the ideal moisture is about 60%. And so this may be in the top layer of soil because there's a lot of worms that actually find their way into the top centimetre, especially of soil, or down just above the soil surface where the dung pats are or the dung piles are. And so if it's very, very dry, they simply won't develop. And if it's very wet, they also get flooded out and won't develop. So they really want the sort of moisture that you get from 2 days of normal rain. And that means if you have 2 days of normal rain, ideal conditions for those worms to develop through to infective larvae. Generally, we find between, about 50% of the eggs that hit the ground in the right conditions do develop through to infective larvae. Okay, once they're ingested, they become adult worms in the stomach. And this picture, courtesy of Jeff Kay from Victorian DPI, shows us the adult barber's pole worms in the fourth stomach of the sheep. You can see they're wriggling away there. They're very active. They're causing irritation. But not only that, they're also sucking blood, and each adult worm will suck 0.05 ml of blood per day. But the larval worms, the fourth stage larvae, will also suck blood. So you can actually get a lot of impact on the sheep due to blood loss, simply due to the larvae being there before they develop through to adult worms. Okay, then the adult worms lay eggs, and we can see that the eggs start to develop under the right conditions if you have those 3 criteria satisfied, which are temperature, oxygen, and moisture. They'll start to develop inside the egg until they become first stage larvae, and then pop out of the egg and then molt again to become second and third stage larvae. Now, the third stage larvae wriggle until they find some water, and they're usually found in a film of water. And in a lot of places, that will be when there is dewdrops on the grass, and they'll accumulate inside the dewdrops. And so every time the animal reaches down, has a feed, they will take in a mouthful of those worms inside the dewdrops. Now, each one of them is only about 0.7 of a millimetre long. So if you get out your magnifying glass and go and look at the pasture outside, you may very well see them, but they're very hard to spot when they're on the grass because they are so small. And their favourite position is down there at the very bottom of the grass sward. And so the top centimetre of soil just below the surface does accumulate a lot of worm larvae, and they'll act as a reservoir to crawl back onto the pasture and infect the animals. But most of the worms are down there in the bottom couple of centimetres of the sward, Once you get up above 15 centimetres, there's almost no worm larvae. They don't like to wriggle up that high. So if you observe sheep, you can see that that's particularly where they like to eat. They put their mouth right down almost to ground level, and they chew away at the sward, and they pick out the grass down at ground level. Goats, of course, like to put their heads up because they're smart. They know where the worms are. And cattle will use their tongue to wrap their tongue around the sward and rip off feed that they swallow. But sheep tend to go right down to ground level. The other part of internal parasites that is very important at the moment is liver fluke. And we can get a lot of clues about how to manage liver fluke from their biology. And we'll talk later about distribution, but just the seasonal impact of worms. We know that the cysts of the liver fluke, the Metasecariae, will survive 6 months at less than 15 degrees. So they'll survive over the wintertime, but they won't survive in dry or heat. And only 5% of them will actually survive through 10 months. So they don't like a dry summer. At the other end, when the adult liver fluke lay eggs, we know that the eggs hatch out in 14 to 90 days. They need to find a host in the snail within 12 hours once they hatch. And that snail, the host, is able to lay 3,000 eggs in that shoulder season period, 10 to 25 degrees. And so that's why in springtime and in autumn, the snails reproduce like crazy and proliferate. That means there's a lot more potential hosts for the liver fluke. Not only that, once the Cercariae get into those host snails, they'll actually clone themselves, and one Cercariae can create as many as 4,000 inside the snail. So when they bust out of the snail, they've really expanded in numbers, and they'll only do that at temperatures above 10 degrees Celsius. So we can work out when are the times with the worst contamination for liver fluke. Okay, now that we've been through the features of parasites in animals that ensures that they get infected with parasites, let's change gears again and move on to pasture and animal management. And the key thing is that we are aiming for low parasite risk livestock properties, because these will be the properties that are robust, they are resilient, they'll be able to withstand the times of crisis when there's lots of parasites around. Okay, so the first question to ask is, what makes a pasture high risk for worms? And this is a time when you can actually use the Q&A box to go in and write some of your answers. What are some of the things that makes a pasture high risk for worms? Now, Fiona, if you could help me through here, let me know when we've had some responses. Beg your pardon? Oh, okay. All right, well, let's put up some of the main ones. So the first one is rain and temperature. If we have very dry paddocks, there's very few worms surviving. If we have rain, if we have a right temperature, such as we've been having, for example, the last few summers over most of Eastern Australia, then we'll have high risk for worms. Say again? Absolutely. Yep. Lots of ground cover, because that provides shade for those little tiny larval worms and also allows them to crawl up onto the grass. Set stocking rather than rotational grazing, and high density or high stocking rate, and only one species. So, for example, if you've got sheep that are rotating pastures with horses or cattle, it gives those pastures a chance to rest while the other species is on them, and that decreases the survival of the worms there. And I'll go through those answers at the end, as Fiona has suggested. Okay, so looking ahead, what sort of rain and temperature can we expect? Well, this is the Bureau of Meteorology's projection for the next 3 months, April to June. And you can see that throughout central and northern Australia, apart from the north coast there, far north Queensland, and into Arnhem Land, where there is going to be a bit of rain, most of it's going to be drier than normal. However, for southern and eastern Australia, including most of the pastoral areas of Western Australia, there's going to be fairly good rainfall, and we're expecting it down in Tasmania as well, a fairly normal autumn to early winter rainfall. So that means there'll be reasonable worm survival, and given that we've just come through a time of very high parasite load, we can expect that to continue into winter. Okay, well, what does the high parasite load look like? Well, we tested a lot of paddocks around Camden, and this is thanks to some really brilliant vet students that we had doing prac work in the Dorbert's lab. And they were able to collect samples of pasture from a lot of different paddocks and measure the number of larvae. Now, we're not alone in doing this. I know that at the Invetus Research Institute in Armidale, they also did a big series of pasture larval counts. And they got some similar results to us. Some of the worst contaminated pastures were carrying up to 40,000 larvae per kilogram of dry matter. Now, if you're asking why we measure it in terms of kilogram of dry matter, well, you know, it's a repeatable measure that we can use across different types of pasture. And also, as a good rule of thumb, you know, a sheep or a goat's eating about a kilogram of dry matter of pasture every day. So we can work out how many larvae that sheep or that goat or that cattle beast would be consuming if they ate from that pasture. And so you can see there's several cattle paddocks there that had between 20 and 40,000 larvae. And we've got some goat paddocks that had 20,000 larvae per kilogram of dry matter. And that means that even if we spelled that paddock for a long time, there's still going to be larvae remaining. Here's a study that looked at the same paddocks at different times of year. And you can see that they started off with very low pasture larval counts. And then a couple of months later, the pasture larval counts went very high, up to 12,000 larvae per kilogram of dry matter. And then they declined later on in the season as it became drier. So that's an indication of what happened on a particular farm. And to know what's happening on your farm, you have to actually do the work to know what effect the season, the ground cover, the animals, and the worm burden in the animals are going to have. Now, larvae on pasture decline at a predictable rate, and that's because they can't eat, they've got stored energy reserves, and these run out as they become more active. And so at 5 degrees, for example, over the winter, the larvae are very inactive, they're moving very sluggishly, they're going to retain all their energy. But the opposite thing happens in the warmer seasons. And as it warms up, they become more active, they use up all their energy, and they die off. And so researchers have been able to work out exactly how long it takes for larvae to decline on pasture. And these graphs, which are published in WormBoss, allow us to work out how long it takes for larvae to decline at different temperatures. Now that means you can look at this table and say, okay, well, I want to prepare a paddock for weaner sheep, for example. And how long is it going to take before 90% of the worms die? And you can work out the time period depending on the average temperature that is going to be ahead in the next couple of weeks or months. Okay, so that tells you how long it takes for 90% of them to die, but you really do want to know what the contamination level was prior to the 90% died, because if you started off with 4,000, you're going to go down to 400 larvae per kilogram of dry matter, which is probably an acceptable risk. But if you started off with 40,000, then you're only going to go down to 4,000 larvae, which is still a pretty high level of contamination. And we know that that's a realistic number because we've actually seen those numbers in pasture larval counts that have been done through our lab and through the Invetus lab at Armidale. Okay, well, let's look at some more tools to reduce pasture worm contamination. So I mentioned before about rotating with cattle. You can also achieve this with dry stock. So wethers, for example, are very hardy. They're very resilient against worms. They don't have very high worm egg counts, and so you can rotate onto a pasture quite confident that they don't have a high level of contamination. And then you can use genetics. Now, there's not much genetics for worm egg count done in cattle, but it is possible. But it's very common for people to select their rams and their bucks. They can even select their ewes or their does on Australian sheep breeding values. That will decrease the amount of worm eggs that those animals produce. Barbavax is a vaccine to prevent Barber's pole worm infection and reduce the contamination of paddocks after Barber's pole worm have been in the flock. And biowormer as well is fed to animals to reduce the pasture contamination by fungus attacking the worm larvae in the dung pad. You can rotate pastures with short grazings. In the south, where there's no Barber's pole worm, you'll get away with a 30-day rotation. But where there's a lot of Barber's pole worm, it's recommended that you use a 21-day rotation. You can spell pastures for longer periods, particularly in dry weather, and take advantage of the natural decline in larvae to allow them to decrease and die out. Low stocking rates and short joining periods. Now, you're probably thinking, what's joining period got to do with it? That's a reproductive index. But we find that people who've got quite short joining periods, and ideally they'd get down to 5 weeks, which for sheep is, 2 reproductive cycles, means that they can mark lambs and get them off the lambing paddocks, which of course are the most contaminated paddocks due to ewes excreting more eggs while they're in that period around lambing and lactation, heavy lactation, and get the lambs off those heavily contaminated paddocks quicker. And the same goes for scanning. So that means you do peg testing, and the multiples and singles dry ewes can be managed differently, given different nutrition, and also allowed to move into fresh paddocks at the appropriate time. Making hay or silage, of course, takes off the bulk of the sward, exposing the ground and the lower part of the sward to UV rays, and they dry out quicker and don't provide any protection for the worm larvae down there. Rotating with cattle, as I mentioned, and the same goes for rotating cattle with sheep, because if you're a cattle producer and you have sheep available, the sheep actually graze closer to the dung pats than the cattle will, because cattle, as we know, have a zone of repugnance where they simply won't graze within 70 to 100 centimetres of the dung pat. But sheep will graze a lot closer and reduce the worm burden around the dung pats, and therefore help the cattle out. Now, the other thing we can do is to feed for resilience. Now, feeding will, to a small degree, increase the immunity against worms, but it actually increases the ability of the animals to cope with worms. And that feature is called resilience. So by increasing protein and energy in the feed, we are increasing the animal's resilience. And it was best exemplified in this trial that was done in Mexico. They had 3 pens of identical lambs, and they were Dorper-type lambs, they were called pelibuis, and they fed them at 3 different rates, 3% of body weight, 3.3 and 3.7%. Now, it seems fairly a minimal change, but it meant that once they'd accounted for maintenance energy in those animals, the group with the lowest feeding rate were able to grow at 75 grams per head per day. So that's called their average daily gain, or ADG. The middle group, fed at 3.3% body weight, had an average daily gain of 125. And the top group, which was fed at 3.7% of body weight per day, had an average daily gain of 200 grams per head per day. I know a lot of our livestock producers with small ruminants, sheep and goats, are aiming for 200 grams per head per day as a reasonable target for lamb growth rates. Then they were given some worms and measured to see how well they went. So after a couple of weeks, they found that the sheep, or the lambs that had the higher growth rates, had less worms. And not only had less worms, they also had more blood, because the barber's pole worms were sucking the blood out of the other animals. And so this is quite a simple experiment, but it illustrated very clearly that animals with a higher growth rate, that are on a bit more nutrition, will have less impact of the worms and are going to suffer less, both in terms of the number of worms and also the amount of blood that they lose or are able to replace due to the worms. Now, if you want to read that article, it was by Cancelis and fellow researchers from Mexico, and it's written up in the Veterinary Parasitology Journal. Okay, so if you are having trouble calculating the amount of feed that your animals are getting, get the MLA pasture ruler, and you can plonk it in the pasture, and that gives you an idea of how much volume, how much actual tons of dry matter you have per hectare. And also you can use it as a way of working out both the palatability and possibly even the protein content of the feed, because you can see how much green content there is in that feed, which gives you an idea of the feed quality. And then, of course, you can back it up with body condition scoring. So by running sheep up the race, putting your hands on, you can use the AWI body condition score guidelines and score all those sheep in between 1 and 5 to see what sort of body condition they're in. Now, this is a very repeatable measure, and it's easy to record. I've got an app on the phone, the body condition score app, and you just go along and you can keep the phone in one hand and take the body condition score while you feel the sheep with the other hand. And that gives you a very good record of the body condition score, which is also related to how well they can fend off the worms. Okay, I mentioned before BarberVax. This is a vaccine made from the insides of the barber's pole worms, made up into a vaccine. Needs to be given 3 times before you get any immunity. But after that, you get immunity for about 6 weeks. And you can find out a lot more about BarberVax from your wholesalers. At your rural retail stores. And the same goes for this biowormer, which is a biological control. You feed it to the animals, and the fungus goes through their gastrointestinal tract and ends up in the dung pat, and then the fungus come out and they will start to kill the larval worms inside the dung pat. And the trials that have been done both in Australia and elsewhere shows that you get up to about 60 or 70% control just from having this in the feed. Okay, Another really important thing about parasites is if you don't have parasites on your farm, then you use quarantine to keep it out. So quarantine is simply knowing and managing the risk of introducing disease. So if you're going to buy, for example, a pen of calves, it's good to know where they came from, what sort of treatments they've had, what sort of background they've had, and maybe even talk to the vendor to try and work out if they're suitable for your farm. If there's a risk of some parasite being carried onto your farm that you don't have, then you have the option not to purchase them. So quarantining really does mean having a good level of knowledge about the different diseases and their distribution. And so you can get help from your veterinarian and put together a biosecurity plan. Biosecurity management is just simply designed to keep animals away from risk. Okay, so this is another little quiz. What are some of the common parasite diseases that animals might have that we need to keep them away from? Now, there's a lot of case studies this year of diseases being spread from farm to farm, region to region. Sadly, it's happening more and more as we become used to trading animals more. And we seem to be trading animals without as much regard for diseases as when we physically buy them in the sale yards or from another property. So some of the common ones that we've found, and you might already have listed them, or you can put them in the Q&A if I've forgotten them. Liver fluke. Now, liver fluke are very easily brought onto a property, and we know that once liver fluke is on a property, they need the snail hosts to survive. But you can use fencing to fence off the places where the snail hosts are most common and reduce your risk. Stomach fluke is another one that requires snail hosts. And so we'll talk a little bit more about the distribution of stomach fluke, but you can actually use knowledge that's available to reduce your exposure. We never want to have lice in goats, cattle, or sheep, but it's very easy to buy them in. And you can do a check for lice, and you can do a risk assessment to see what is the potential for them to carry it. Coccidiosis usually occurs in muddy conditions. Fly strike, some paddocks are more, some paddocks are better for fly strike. For example, very protected paddocks where the flies aren't blown away in the wind will have a lot more fly strike, and so you don't want to put sheep there that are quite susceptible. They're better off going into a paddock that's got wind and doesn't have any fly strike. Worms. Now, we do a lot of testing for worms, and we might have one region. A good example is New South Wales, Southern Highlands, where, you know, there might be 3/4 of the farm have barber's pole worms, but there'll be some farms that never have them. And those livestock managers will use quarantine and biosecurity to keep the barber's pole worms away. For cattle, tyleriosis is a very common disease on the east coast and does appear also in the southwest of WA around Walpole, and we can keep an eye out for that. Tick fever, of course, in those places in the north where there's ticks, and then the different types of ticks themselves, bush ticks, cattle ticks, nuisance flies, and even paralysis ticks. Okay, well, let's move on to monitoring animals. And if you're looking at your flocks and herds every day, you can actually see signs of worms, for example, in sheep and goats. Now, we get bottle jaw, we get pale mucous membranes, and they are comprehensively outlined in the ParaBoss website. So if you have a look, for example, at your sheep and you see a soft fluid swelling under the chin, that's bottle jaw. It's often a sign of barber's pole worm, but it may also be a sign of liver fluke. Another good place to look is using the Pharmachar examination method, where you push in the eyeball and gently allow the third eyelid to come across, roll out the lower eyelid, and examine it for colour, and you can see a difference between animals that have a lot of colour, so a pink colour, to animals that have a very pale colour, and that's the sign that they are probably anemic. And the PharmaChar system, if you're trained in the PharmaChar system, it allows you to gather a lot of information very quickly about how well your animals are travelling with regard to anemia, which is a sign often of Barber's pole worm, but can actually be also an early warning sign for liver fluke, or in cattle, theileriosis, as well as Barber's pole worm. Now, in cattle, it's often not that convenient to look at their eyelids because their head's a fairly dangerous place to look at. But if you've got them restrained in a crush, you can look in the vulva and see the colour of the vulva. Another thing that we can do is count fly numbers, because particularly for buffalo fly, we know that there's economic thresholds. And when we count fly numbers, we can see what level of flies there are on animals and what are the management that we can do to get those flies off. And a very effective method are the buffalo fly traps. And when I was working around Kenilworth in the late 90s, early 2000s, a lot of our cattle producers used buffalo fly traps. Yes, you may need to put two of them end to end, because the buffalo flies, can actually fly around them. But if you put them in a place where cattle go through regularly, such as the entrance to a watering point, a trough or a dam, or if they're like these dairy cows coming into being milked, coming into the dairy, then they can be very effective ways of getting the buffalo fly off and actually killing the buffalo fly. Okay, another method of monitoring animals is with worm egg counts, and this allows you to see over the horizon before the animals even get sick. You can use individual tests, pooled tests, and also do liver fluke tests. And I put in a plug here for the ParaBoss WEC QA certification system. You know that if your lab is WEC QA certified, then they're producing consistent results. Okay, let's move on to geography and genetics, because a lot of the issues with parasites relate to geography. And here's an example. This is an organic farm in central Australia, just north of Alice Springs, and it was in the news recently for changing hands. And that's a big place, running cattle organically. And they're able to do that because they're in a place that's got a low rainfall. And so they don't have a lot of insect problems and a lot of internal parasite problems that we do in the areas with higher rainfall. And a good example is 3-day sickness. So this is spread by biting midges, and we know the distribution because Animal Health Australia very kindly maps the distribution each year through their monitoring program, and they can tell us where both the different viruses and the vectors, the insects that spread those diseases, come to each year. Another one is the host snails for liver fluke, and this is just one of the liver fluke host snails, and this is one of the stomach fluke host snails, and we can actually look at the Atlas of Living Australia and work out just where those snails are likely to be found. You can see there's none in Central Australia, which makes it ideal for zero chemical use animal parasite management. So going back to WormBoss, there are regional programs that allow you to look at the best practice monitoring and management systems for different species of animals, cattle, sheep, and goats in those different regions. Another regional problem is the distribution of bush ticks and theileria, and you can see that makes movement of animals very predictable. If you're moving from a ticky to a free region, then you're putting the animals in the free region at risk. If you're moving from a free to a ticky region, you're putting the animals that you've moved at risk. and free to free or ticky to ticky doesn't really make any difference as far as bush ticks and theileriosis goes. But knowing the distribution makes it possible to plan and reduce the risk. So if you want to know more about that, consult your local veterinarian, your LLS or district veterinarian, or you can find an advisor on the ParaBoss certified ParaBoss advisor page. Now, coming to genetics, these are the MacArthur flock of merinos that are located at Elizabeth MacArthur Agricultural Institute, which is only about 10 k's from where I live in Camden. And the reason why they're so remarkable is because they are small, plain-bodied merinos that are very, very resistant or unlikely to get fly strike because they're so plain. And we can actually have a selection for different features, for some of the physical features that predispose to fly strike, or even for worm egg count, which is an indication of how wormy they are, using the Merino Select or the Sire Select ASBVs or Ram Select, or even Buck Select that's there for selecting goats to allow us to select for the features of those different types of animals. And of course, for cattle, there's a lot of genetic material available that enables animals to live in tropical areas and be more resistant to ticks, for example, and to certain types of tick fever so that they can become more resilient, and also crossbreeding programs so that we can have, for example, these animals that have got both the benefits of high meat quality and adapted to tropical conditions so that they can cope with the warm, wet conditions in the tropics. And just a reminder, we can breed for worm resistance in goats as well, and all the information there is on your WormBoss webpage. Just a final thing, this is a photo sent by our colleague Sarah Heffernan from down near Wagga Wagga, of some dung beetles active in a dung pile, and they can be very useful for breaking up dung pats and making them less suitable for habitat for buffalo flies and for other things that live in dung. And there are some chemicals that have been certified organic, and so a good example is Extinosad. So if you do have a crisis with, for example, blowfly strike, or for lice in sheep, then you do have an option for treating them. Okay, and there are certain rules about using chemicals in certified organic properties. So, for example, drenching in the first trimester only. But again, I'm not an expert on this, and I'd strongly encourage you to consult your organic certifier or auditor to make sure that you're compliant with the correct rules for your market certification. Okay, let's just go through the take-home messages. The first one is geography and biology are critical. You can't fudge this. You have to know the distribution and the conditions for the key parasites and the other diseases that occur. For pastures, you have to keep your larval contamination and vectors down, the numbers very low, in order to have a farm that is robust against parasites. And that includes low stocking rates and rotational grazing. When you're monitoring, worm egg counts are going to be a very valuable tool, but you can also use physical examination and even behaviour of animals, because guess what? No surprises. They slow down when they've got a big worm burden. They stop walking and they stand still because they've got a lot of inflammation in their guts. You can use fly counts. You can do fleece monitoring, fly traps and weather as ways of predicting when to intervene for buffalo fly or for blowfly strike. And you need to have a contingency for animal welfare to make sure that animals do get appropriate management if the worm burden or the external parasite burden is too high. Now, with stock, you have to choose the suitable species, breed, and stocking rate for your location and disease risks. Once you've got them, you can use genetic selection and vaccination for immunity to parasites and other diseases. And nutrition is a great tool to improve resilience to parasites as well as other diseases. Now, apologies, Fiona, I have gone slightly over time, so I'll return you back to our host, who'll be able to help out with comments and questions.
Thanks, Matt. It was so informative. I didn't want to stop you talking. So we have a couple of questions that have come through the Q&A. If you would like to ask Matt any questions, now is your opportunity. So I'll start with the questions that I have already, but now's your time to type them into the Q&A if you would like any help with anything from Matt before we sign off. So the first one, Matt, which you did address briefly in the presentation, was how does mowing or slashing affect the worm numbers on the pasture or the crop?
Yeah, that one's from Mandy. Now that's actually a bit of an open-ended question because there are a lot of variables in there. If you've got a very highly contaminated pasture and you mow and slash, then you will take away some of the worms physically, and you will expose all of the remaining worms to higher levels of UV radiation and direct sunlight in the direct sunlight. So it will actually improve. But just on principle, you're better off using as much of the pasture as you can by bringing in cattle or dry stock that aren't as susceptible to worms and getting the maximum utilisation rather than just mowing or slashing.
Thanks, Matt. I guess it also affects if you're going to graze it again straight away, which sheep wouldn't be ideal because then you're allowing them to graze quite closely to the soil where they could come into more contact. Would that have a bearing?
Yeah, it would. Yeah, they'd be grazing lower and probably getting more worms closer down to the ground.
The next question is a great question. How should we safely dispose of expired drenches?
Yeah, now there's an organisation called Animal Medicines Australia, and they put aside money from the sale of every single drench bottle, apart from the really small ones that can go in the bin, to dispose of drenches. And so, dispose of drench bottles. So with the drenches themselves, if you can find a place that's far away from a waterway and have a disposal area and rinse out the drenches themselves in that disposal area, then they're broken down very quickly by the bacteria in the soil. And the drenches themselves don't pose any threat to the animals or the environment because they are broken down. And then the actual drums can be disposed of using the drum muster sites, and they're located in most country tips.
Sorry about that, Adam. We've got a bit of feedback with our mics on. But that brings us to the end of our question time anyway. We have no more questions. In response to your first question that was given, Matt, might get you to just mute. We had some feedback which was eating pasture load to the ground and stocking rates and short grass and ground cover were some of the responses.
Answered them all.
They did. They were very clever. Well, thank you so much to everyone who joined our webinar today. It was great to have you all on board here, and we look forward to seeing you join us again at ParaBoss next month. So thank you very much, and thanks, Matt, for joining us.
Pleasure.
Bye for now.